If you imagine a journey through the solar system that is no longer defined by urgency, direction, or purpose, but instead unfolds as a continuous and slow drifting through vast, silent space, then at some point, this journey naturally brings your attention toward Mars, a distant, ancient world that has been moving around the Sun for billions of years in a perfectly stable and uninterrupted orbit, unaffected by time in any human sense, existing instead in a scale of time so large that it becomes almost impossible to fully comprehend. From the far reaches of space, Mars appears as a small, softly glowing reddish sphere suspended in deep blackness. There is no noise, no vibration, no sensation of movement, only the quiet visual presence of a planet that has remained in essentially the same form for an unimaginable span of cosmic time. The sunlight that reaches it has traveled for minutes across the vacuum of space, uninterrupted, unaltered, arriving gently, almost carefully, as if even light itself slows down in respect to this distance. As you begin to move closer in imagination, the surface of Mars gradually becomes more detailed, but never abruptly. It does not reveal itself all at once. Instead, it unfolds slowly, layer by layer, as if the planet is allowing you to notice only what you are ready to perceive. Vast plains stretch endlessly across the surface, broken only by ancient impact craters formed during the early history of the solar system, when collisions between celestial bodies were far more frequent than they are today. These craters are not active, not changing quickly. They are geological memories, preserved in stone, each one representing an event that occurred millions or even billions of years ago. Between them lies fine, reddish dust that has accumulated over immense periods of time. This dust is not simply scattered material, it is the result of continuous, extremely slow weathering processes that have been operating for eons, breaking down rock into smaller and smaller particles under conditions of extreme dryness and thin atmosphere. The characteristic red color of Mars is one of its most defining features. This coloration comes from iron oxide, a compound formed through the gradual reaction of iron-rich minerals with oxygen over long geological timescales. On Earth, this same process produces rust on metal surfaces, but on Mars, it has occurred on a planetary scale, slowly transforming almost the entire surface into shades of red, orange, and muted brown. The result is not a bright or aggressive color, but something far more subdued and uniform. The entire planet feels visually cohesive, as if it has been painted with the same brush over an enormous span of time, without interruption or contrast. There are no sudden visual breaks, only continuous variations in tone and texture, creating a landscape that feels calm, stable, and almost meditative in appearance. As the imaginary viewpoint moves even closer, subtle variations in the terrain begin to emerge. Slight elevations, shallow depressions, and long, eroded formations become visible, each one shaped by processes that unfolded very slowly over millions of years. There are no rivers actively flowing across the surface today, no oceans, no large bodies of liquid water. Instead, there are only traces, faint structural imprints left behind by ancient environmental conditions that no longer exist. The atmosphere of Mars becomes more relevant at this closer range. It is extremely thin, roughly 100 times less dense than Earth's atmosphere, and composed primarily of carbon dioxide. Because of this, the way light interacts with the environment is fundamentally different. There is less scattering of sunlight, less diffusion of color, and a much more direct transmission of light to the surface. As a result, the sky does not appear deep and saturated like Earth's blue atmosphere. Instead, it often appears pale, almost fragile in appearance, shifting between soft tones of beige, dusty pink, and faint yellow, depending on the amount of suspended particles in the air. This creates an overall visual impression of delicacy and stillness, as if the atmosphere itself is quiet and unobtrusive. Light on Mars behaves in a similarly gentle way. Shadows are not sharply defined. Instead, they extend gradually across the terrain, blending softly into surrounding surfaces. This creates a visual rhythm that feels slower and more continuous than what is typically experienced on Earth. Even illumination seems to unfold in a calm progression rather than sudden change. Temperature conditions remain consistently low across the planet. On average, Mars maintains temperatures around -60 degrees Celsius, although this varies depending on location and time of day. Near the equator, during daylight hours, temperatures may rise slightly, but this warmth is temporary and fragile. This cycle of slight warming and rapid cooling repeats with each rotation of the planet, but always in a predictable, stable pattern. There are no sudden climatic disruptions, no chaotic weather systems in the way they are known on Earth. Instead, everything follows a slow and consistent rhythm, as if the entire planet is operating on a long, uninterrupted cycle of calm repetition. Even wind, when it occurs, behaves differently here. It does not carry the same force or sound as it would on Earth, because there is not enough atmospheric density to transmit strong pressure waves. Instead, it gently lifts fine dust particles and redistributes them across the surface in slow, almost imperceptible movements. Over time, these subtle shifts contribute to the gradual reshaping of the landscape, but never in a sudden or dramatic way. And as this distant world continues to reveal itself, layer by layer, detail by detail, there is a growing sense that everything here exists on a different scale, a slower scale, a quieter scale, a scale in which change does not rush, but unfolds gently across vast stretches of time. As the slow, imaginary approach toward Mars continues, the surface begins to reveal structures that are not just visually impressive, but also deeply tied to the planet's long geological history. These are formations shaped not by sudden events, but by processes that unfolded gradually over millions and billions of years, each layer of terrain acting like a record of time itself, preserved in stone and dust. One of the most striking of these structures is Olympus Mons. It rises from the Martian surface not as a sharp peak, but as an immense, spreading dome of volcanic rock that extends across an area larger than many countries on Earth combined. Its height exceeds 20 kilometers, making it the tallest known volcano in the solar system, yet its presence is not imposing in the way a steep mountain would be. Instead, it feels almost integrated into the planet itself, as if it is not something that was built, but something that slowly emerged through repeated, extremely gradual volcanic activity over vast periods of time. The slopes of Olympus Mons are so gentle that, in many places, they would be barely noticeable if you were standing on them. The incline stretches over hundreds of kilometers, rising so slowly that the concept of climbing loses its usual meaning. There is no abrupt change in elevation, no sudden shift in terrain, only a continuous, almost imperceptible upward transition that reflects the extremely low viscosity lava flows that formed it long ago. The surface around Olympus Mons carries the same sense of quiet stability. There are no signs of recent eruptions, no active lava flows, no visible disturbances. Instead, everything appears frozen in geological time, as if the volcano has completed its active phase and now exists in a long period of rest that may last indefinitely. Moving across the planet, another immense structure gradually comes into view: Valles Marineris. Unlike volcanic formations, this feature is not built upward, but carved downward into the surface of Mars, forming one of the largest canyon systems known in the entire solar system. Valles Marineris stretches for thousands of kilometers across the Martian equator. In some regions, it reaches depths of up to several kilometers, creating enormous vertical walls that descend into shadowed regions far below the surrounding plains. The scale of this structure is so vast that it is difficult to perceive in a single view. It is not something that can be fully seen at once, but rather something that must be understood gradually, piece by piece. If you were to stand at the edge of this canyon system, the experience would not be defined by sound or movement, but by silence and depth. The walls would extend far into both directions, disappearing into the distance, while the ground beneath you would feel stable, ancient, and unmoving. There would be no echoes, no flowing water, no atmospheric disturbances, only the stillness of a formation that has existed in essentially the same state for millions of years. The geological layers exposed within these canyon walls reveal a long and complex history. Each layer represents a different period in Mars's evolution, much like pages in a book that has been slowly written over immense spans of time. Some layers suggest past erosion by wind, others hint at the possible presence of ancient water activity, while others reflect volcanic or tectonic processes that occurred in the distant past. These structures collectively suggest that Mars was not always the cold, dry, and quiet world it appears to be today. Scientific evidence indicates that in its early history, the planet may have had a significantly thicker atmosphere, capable of supporting liquid water on its surface under certain conditions. During that ancient period, water may have flowed across the landscape,